Question number 4 of the worksheet Forces in Motion. A boy runs from a point A to the point C. He pauses at C and then walks back towards A until it reaches the point B. We can see this through the graph that this is the first part of the motion where the boy goes from A to B. So this distance represents, sorry, A to C, not A to B. This distance represents A to C movement, and then he pauses for a bit. So this is the pause where there's no speed. The speed is 0. That means it's not moving. And then walks back towards A until reaching the point B. So this point B from C would be this region. Okay. So he's moving from a point A to a point C, then stopping here for a while, and then moving in the opposite direction towards a point B. Okay. The boy runs and walks in the same straight line throughout. Find the distance AC and AB. Okay, so this is the distance AC, area under the graph. So that would be 70. So part 1, AC, so distance would be equals to 70 meters. Okay, next we need the distance from A to B. So this distance. So this would be this distance, which is 70 meters, and this distance subtracted with each other. So this is the distance B to C or C to B. And this is 4 times 15, 60. So this is a distance of 60 meters. This was a distance of 70 meters. So in between, from A to B, the distance would be 70 minus 60, which is 10 meters. Part 2 says sketch the graph of x against t, where x meters is the boy's displacement. Okay, x is the displacement, x meters, and t is the time. Okay, so at time 0, the displacement is 0. Then at time 10, the displacement is 70. So I'm going to mark 10 here and 70 here and make a line like this. Okay. Then the object or the boy is at rest for the next 5 seconds. So I'm going to make a straight line for the next 5 seconds because there's no change in displacement. As the boy is not moving, the displacement does not change. And then this represents the return journey, and the boy returns towards the starting point till a distance of 60 meters. So we will draw this downwards. This should cover a 60 meters distance. So 70 minus 60 would be 10. And this should be 30. Okay. I don't like the scale that much. If this is 15, 30 should be somewhere over here. So I'm going to fix that. And then we would be done. Okay, 15 is here, 30 should be double here. And this should be x, sorry, t. And this should be it. Stops at 10. Okay, this is the displacement time graph.